Hey, this is Jesse with Create This. It is late March 2025, and back in 2024, I made a video called Software Engineering is Dead. And in that video, I predicted that at some point in time, you would be able to have a software engineer basically as a PC or a computer somewhere, possibly the size of a desktop, and you would be able to get work out of them just like you can a regular software engineer. I am a software engineer. I've been one for 24 years at this point. So this subject is kind of near and dear to my heart. Beside me, just a year later, you see the hardware to run Deepseek-R1 locally, and Deepseek-V3 is probably more likely what I'll be using. But it looks like we're there. It looks like in a desktop-sized PC, you can now run an AI that's capable of functioning as a software engineer, at least on some level. So let's talk about the parts. I acquired all of this over the course of about 2 months, and I don't actually remember some of the model numbers, but this is the server case, tower, power supply. There are 2 heat sinks that I bought on eBay. We've got 2 CPUs, so these are EPYC 9355 CPUs. They're like pretty beefy. I think they're 32 core. They're about $3,000-ish each in 2025 money. I've got, I believe it's 678 gigabytes of NEMIX DDR5 5600 megahertz PC5 44800. So, you know, LLMs require a crap ton of RAM, and so that's what we're getting there. And then we've got a 990 Pro NVMe, 4 terabytes for storage, and for the motherboard, we've got an a Gigabyte MZ73-LM0. And then over here, I've just got some things to help me record the BIOS and do screen recordings and stuff like that, because the last time I've done a PC build was back in 2015, I think. It's been a while. I'm going to have down below on the little scrubber bar little checkpoints. So if you get sick of hearing me talk, I tend to drone on. Just skip ahead to the section you're interested in. I'll cover everything in this video. I'll cover everything from assembling the PC to installing the software, and also running some queries with DeepSeek and seeing how fast it runs, because I don't know about you, but that's what I'm personally interested in seeing the most. Oh, and I almost forgot. I bought all of this with my own money because I'm an idiot and I hate money, apparently. So, you know, you're getting my opinion here as the build progresses. Nobody is paying me to do this. There are no vested interests. This is just some guy who has been a software engineer for a long time and wants to see the AI that can replace him in a little box. So let's get to it. Okay, so it looks like we're putting on an E motherboard. They're labeled different things, like this one says M, that one says AM, EAMI. But this, and this all say E. This one also says E, but I don't think that one fits. And so does that one. But I don't think there are holes for that one. So also be careful with these little heat sinks here. They're fragile. I moved one a little bit by accident. I was taking a look at this motherboard, and I realized that it did not ship with a battery out of the box. I can't find one in the box anywhere. The user manual doesn't say what kind of battery it takes or the orientation, and there is no documentation online about it either. I did find a YouTube video that showed how to install a battery on one of these vertical carriers. So I'm going to install a CR2032 the way that they do it. and hopefully I get it right. Not installing a battery on your motherboard is wild work, man. I don't know. It's crazy. Should be correct. Maybe. Okay, the next step of this is going to be to supply power to the motherboard. There is a IPMI BMC chip on this motherboard. I'm not like super into server technology, so I don't really know what that means, except that it means that I think I can connect an Ethernet cable to the back of the board when it's powered up with no RAM on the board and no CPUs installed. And I can flash the BIOS because this is a revision 2 board and I need it to be a revision 3 board in order to run my, my CPUs. Let's power it up and see if that gives us a LAN interface. All right, I'm just going to freehand this one with my cell phone. So I've got it plugged into the management LAN port. There's 2 other LAN ports, but the management LAN is the one at the top. I've just got the power cable plugged in, and there are lights on. So let's see if it is accessible via HTTP. Okay, so I tried flashing the firmware on the board without CPUs installed and without RAM installed, and it doesn't appear to have worked. It says that it flashes, but then it doesn't actually flash. So maybe it needs a CPU installed in order to do that. I think I'm going to install some CPUs and see what happens. Yeah, that's nerve-wracking. Man. Screw tightening torque, 13.5 kilograms per centimeter. Let me get a torque wrench. Okay, my conversion calculator says that it's 11.7 inch-pounds. 13.5 kgf per centimeter translates to 11.7 inch-pounds. So, let's see. I probably over-tightened it a little bit. All right, that's fine. Let's just go all in and put the second one on. All right, let's install some heat sinks. All right, has a heatsink compound on it already. Doesn't appear to be an up or a down. Okay, I had to go to AutoZone for an extension because I couldn't get my torque wrench deep enough to do this. So, no big deal. Okay, that's one. I've installed 2 fans. I've got the heat sinks. There are 2 more fans that go on the other side, but this motherboard doesn't have enough CPU fan headers for them. So I'm going to have to either find like a splitter or like a controller or something for those. But I figure these 2 will probably be enough for now. It'll at least be enough to get testing and software installed and stuff like that. So we'll see what happens. Let's do RAM next. Might as well. I don't have an electrostatic strap, but I'm just being careful with all of this to make sure that I'm touching the metal frame of the case as I touch other components. probably not as good as an electrostatic strap, but it's what I've always done, so. All right, at this point, we just need to run power. So this cable wouldn't reach. I tried routing that along the underside, the back side of the case. It wouldn't reach. I was able to route the CPU power, auxiliary power cables. Those come in over here. And also these PCIe connectors, they didn't want to go on the back either because there's not really anywhere for them to go. So they're on the front. There's a front panel USB right here. It's kind of under a lot of strain. I don't really like it, but it's right there. I also hooked up the reset switch and the hard disk drive light. There are a couple of case front panel things that aren't going to work, like HD audio. There's nowhere to put that on this board. It doesn't care. There's also like one or two more USB for the front panel that there's just nowhere to hook them up. It's a server board. Let's do the M.2. All right, so I read some user manuals and looked around and stuff, and it's kind of wild. Like, I guess this case didn't actually come with any case fans, so I'm gonna have to buy some. I've got like some mounting points for like 120 millimeter fans there and up there and stuff like that. So no big deal, I'll do that. But for now, let's turn it on and see if it boots and see if we can, you know, if we haven't flashed the firmware yet, let's see if we can do that. Okay, it is a couple of days later, but I wore the same shirt for you so you wouldn't be confused. That first night, when I booted it up, it became immediately apparent that I needed more cooling in here because, you know, I just didn't want to run the CPUs and have them burn out for any reason. And I was checking the temperature sensors in the BMC, and the LAN in particular gets really hot. And I ended up putting a window fan right next to the case, and even that didn't really seem to be enough. So I immediately that night ordered some 120 millimeter fans, and I also ordered these fan splitting cables so that I can have both fans on the CPU coolers attached to the same controller. So let's go ahead and install all of this. We'll figure out what to do with that in a second. So I couldn't find in the specifications anywhere the amperage of that CPU fan header. Most of them are like 1 amp, so maybe it's 1 amp, I don't know. Yeah, so I think I installed those wrong. I think they blow the other way. I was intending for the air to go inward, and I think it's coming outward. I don't see any directional arrows on them, but I think they blow this way, so. The machine is attached to the LAN. The power supply is turned on, but the machine itself is not turned on. So the IPMI on the motherboard is on, and it is operating a web server right now. So if I went into my router and I could see that the machine was 192.168.0.145 for the IP address. That's what was given out in the DHCP lease. You can go to that in the browser and you get this interface. But in order to do that, I'm on a Mac. I had to find the Google Chrome binary and start it up with -- ignore certificate errors. Otherwise, it wouldn't show me the interface. So now you can go in and the username is admin. Password is the serial number on the motherboard. It's the part after the slashes. So mine starts with 3/H/, and then it's the part after that without any spaces. Okay, there we go. There we go, we're in. Okay, so we can go to the maintenance mode and we can look at the firmware information. My BMC firmware is 130416 with this board, and my BIOS firmware is F08. So I've tried already flashing different BIOS firmwares, and I can't get anything to stick. So I think the problem is that the BMC firmware is too old. So on the website, they have BMC firmware 130613. So that's higher than 130416. So let's try to flash some BMC firmware. When I open up the zip file, I have this firmware directory in it. I've already tried this bin file and that didn't work. So let's try the IMA-ENC file. So it's a BMC type. We're just going to overwrite everything. This looks promising. Man, that looks amazing. All right. All right, well, that clearly did something because we have a new interface. All right, lots of new stuff. Go to maintenance, firmware information. Okay, so BMC is 13613 and BIOS is still F08. So let's go ahead and flash a new BIOS. I have high hopes that this is going to work. This is the latest BIOS that they have available, 35. See if it took. Nope, still says F08. I'm just going to wait a couple of minutes this time because it says to wait. Maybe that step is critical for some stupid reason. Okay, it's been 2 minutes. Let's log in. Nope, still F08. Let's just look at the KVM real quick, see what happens. Powered it on. Fans turned off. Oh, they got quieter. Didn't turn off. Huh. Fans started up again. Yeah, I don't think this is useful. Turn that off. 07. So I realized that during that update process, at some point it went from like F08 to like R07. And I think I finally figured out what it was. So I had to turn the machine on. I had to do power control and turn it on in order for the BMC to actually flash the BIOS. So when you go to maintenance and then you do firmware update and then you put a BIOS in here, it's like it primes the BMC to flash the BIOS, but then the BMC doesn't actually do the BIOS update until you turn the machine on. So yeah, so we're good. We've got the latest BIOS now, R10. Okay, folks, this is the part of the video where I'm going to save you a ton of time. You may be smarter than me, you may be luckier than me, but it took me a day to figure all of this out through trial and error. So pay attention and I'll save you a ton of time right now. So I have Ubuntu 24.04.2 server, LTS, installed on this machine right now. My daughter wants to call the machine Larry, so we're going to call him Larry. It was very difficult to get this installed. And the reason why is I've come to the conclusion that either the USB chipset is bad on this revision 2 board that I have, And I've seen another report on Reddit of someone else having a problem with the USB chipset on these boards. So it might be like a widespread thing, or the driver that ships with Linux is bad. And if it's the driver that ships with Linux, it's the driver in version 20, version 22, and version 24 of Ubuntu, because I tried all three of them. So no matter what I did, I could not get USB ISO images to read successfully and without errors. I kept getting checksum errors and corrupt files and all kinds of stuff, right? So I think the USB chipset is either bad or the driver's bad. Now, for the workaround, the beautiful thing about this is the KVM in the IPMI BMC software here has a browse file option for CD image. So we don't even need USB. We can just load the image up directly over the internet or over the local LAN here. So we're going to do that, or at least we're going to try to. In practice, it was a little tricky for me to get this to work. It took me a few tries before it would take it. But once it did take it, it was very reliable. So we're going to try a few things, and we'll see if we can simulate what I did. And we're going to reinstall the entire operating system, okay? So let's get started. We're going to power cycle the machine first. Actually, first, we're going to go to Browse File here. No. Okay, let me back up. My bad. If you want to download Ubuntu, you're going to go to, I just did a Google search for Ubuntu server download, and this is what came up. Ubuntu.com download/server. 24042 LTS is the latest LTS version at the time that I'm making this video. If it's something else for you, that's fine, try that. You can also try the latest version that's not LTS, but I don't really like those because they're not as well supported. So you do you. If you're the bleeding edge kind of person, then do that. Okay, so you're going to get into your KVM. After you've downloaded that file, you're going to browse to the file, and you can see that I've got all three ISO images here. I'm just going to pick the 2404 version. I don't know what this media boost does. I'm going to be honest. We're going to try it. We're going to try checking it because I want to see if it goes faster. So, because it was very slow the first time. We're going to power cycle the server, okay? Now, I tested it, or I timed it. My server takes about 1 minute and 45 seconds to power back up to just the BIOS post that says Gigabyte, okay? So I'm going to shut up, and through the magic of editing, we're going to breeze through this. Okay, we're going to do start media. We're going to do function delete, control delete, option delete, command delete, because I have no idea which one it does on the Mac. 35 KB, that's a good sign. Okay, I'm going to go over to boot order. CD DVD is first. We're going to turn off the hard drive. Virtual CD-ROM, that's what we want. We want the virtual CD-ROM. Boom, that's first. Okay, now we can have the hard drive. Okay, save and exit. See if it works. Our kilobytes are going up, that's a good sign. We don't see the post from the hard drive, that's also a good sign. Okay, E, we press the E button on the Grub bootloader. This is for your own sanity, okay? So I can zoom in just a little bit here now. I want to keep this at 800 by 600 because anything more than that on this tiny little screen is just going to blow out my window. If you've got like, we're going to do video equals 800 by 600. If you've got a huge monitor, feel free to not do this, okay? But I have a tiny little MacBook Pro, and this helps me immensely. So I'm going to do FN on my Mac, F10. You would just do F10 if you have a regular keyboard. And we can see that the kilobytes is just blazing. We've got media boost turned on, so hopefully that makes it a little faster than it was the first time. The first time when I did it, it was pretty horribly slow. Okay, that was still pretty slow. Maybe it was a little faster than without media boost. I'm not really sure. The virtual CD-ROM is slow. It's no big deal. Okay, so we're gonna press enter on English because that's what I speak. Press done. Press enter for Ubuntu server. We're gonna let this auto configure. So I've got my management LAN attached, and I've also got the regular 10 gigabit Ethernet attached to the same switch. So that's what, this is the regular one right here. So we're going to click done, enter, proxy address, nothing, enter. Okay, so it's going to go out and do a test on this mirror server. That's totally normal. Now, when I loaded 24042 from USB on this motherboard, it would fail as soon as I pressed done. So this is the test of whether or not the virtual CD-ROM is better. And also this mirror test is way faster from the USB. I'm not sure why that is. Okay, so this error timeout was reached. That appears to be perfectly normal when using virtual CD-ROM. It still says this mirror location passed tests. So now we're going to press enter on done. And lo and behold, we get past this screen. That's amazing. So we're going to use the entire disk. So we're just going to press down. I'm not going to encrypt it. You can encrypt it if you want. I don't know how that works on this. I encrypt things on Macs. I don't do that on Linux yet. So I'm just going to press return on done. And I'm going to keep the defaults because I don't care. I'm going to press return on done. Are you sure you want to continue? Continue. My name is Jesse. Your server's name, Larry. My daughter has spoken. Pick a username, Jesse. Password, enter on done. Skip for now for Ubuntu Pro. I am going to install OpenSSH server. I'm going to use the heck out of that. Enter for done. And then if you want to install any of these, you can. I don't know that any of them are particularly well targeted towards LLM machines, and that's what this one is going to be for me. So I'm just going to press enter on done. You can see that the CD-ROM is just screaming in the background. Okay, installation's complete. So now we're going to reboot. And we're actually going to stop the media too. We'll reboot first, and then we'll stop the media, and then we'll press enter. BIOS post. I'm not going to go into it. I'm just going to leave it alone. We'll see if it boots up. Look at that. That's a beautiful thing. We're in. We've got Ubuntu. We can see on the sensors, I've got the case lid on, the side and everything. And at rest or near it, I'm getting pretty decent CPU temps. The only one that concerns me is the OB LAN temp, and I'm going to play with that. I've got a few fan options that I'm going to put in there. I'm going to swap out the case fans with like 140 millimeter fans and do some other things. But for now, it's within like workable levels, but it's a little high for my taste. But I'll fix it. So going over to the machine, let's see here. We'll do top on it. I'm running this within a screen session. And we can see that Ollama is running. It has 703 gigabytes of memory resident. The machine has 773 total and practically nothing free. If we do df-h, we can see that I have a data partition I have currently Deepseek-V3 and Deepseek-V3-0324 installed, and it uses up about 1.3 terabytes of that data partition. I moved Ollama's data repository over to this data partition. So I've got 2.1 terabytes free. Man, this gets used up really fast. I'm probably going to end up buying like a CPIO hard drive. I think they're faster anyway. But anyway, maybe it's MCIO, whatever. I'm not a tech guy. I'm not a tech hardware guy, put it that way. I'm a software guy. So the moment that you've all been waiting for, let's do this. So I took I think his name is Lord Oliver. I took Lord Oliver's Deepseek-V3-0324 and the Q8, so the full, like, 671b, and I think he had like a custom prompt on it because he kept talking about YouTube scripts unprompted. So I I copied the model file from the official Deepseek-V3 Q8, and I applied it to his, I don't know what you call it in LLM terms, but the basically the data for the model, and then I built a new model from that. So if we run it, there we go. So we're getting about 7.71 tokens per second. I've seen that go down to like 6 in my testing. I've just sent like basic code queries to it. I'm a software engineer by trade, and it's one of the reasons why I'm building this machine. It's nice to have a machine that won't snitch on me whenever I give it proprietary code. I don't have to worry about that code like going out into the void and being used to train somebody else's model. So in the stuff that I've given it so far, it seems to do really, really well, but it's about six to 7 tokens per second. So pretty cool stuff. I'm sure that it will run R1. I'm less interested in R1. I'm more interested in V3. And I think the token rate is going to be a little lower. The other, I don't know. I think that I read that it would be like 2 tokens, 2 to 4 tokens per second, something like that. I haven't tried it yet, honestly. One thing that I will say is, let's see, in the system inventory, it detects my CPUs just fine. I've got dual 9355s, but the DIMMs, it does not detect the DIMMs properly. It's saying that they're 4800 megahertz, and these are sold as 5600 megahertz DIMMs. So if I can bump that, I've got a support request out with Gigabyte for the MZ73-LM0, and if I can figure out a way to bump this, I'll get a little bit of a speed boost out of that. So let's see. Some of you might have been hoping that I would give you the full instructions, like a full real-time walkthrough of how to set all of this up. It took me a couple of days to get it working. So what I did instead is I gave you the video of installing the operating system and logging in. So from that point on, I started taking notes. And so you can see these notes at github.com/createthis/Larry, because Larry is the name of the machine, as my daughter named. So I go through everything that I do. I even set up a local etc hosts file because I'm on a Mac communicating with this, and I nickname it Larry. I set up public key authentication with SSH. I install Ollama. I create the data partition and expand it to like 100% of the available data. I move the Ollama data dir to the data partition. I install Deepseek-V3. I use Screen for that so that when my SSH session drops because my laptop goes to sleep, I don't stop downloading it. And then I also show how to install Deepseek-V3-0324 step by step using Lord Oliver's version, and also how to move the model file over. So check that out. Should be everything that you need. If I forgot anything, feel free to leave a comment down below. All right, it is very late, but Jimmy with Gigabyte server support gave me a reply, and I just wanted to give you an update. My DIMMs are now running at 5600 megahertz. Pretty sweet. So the way we did that, I've updated the Larry README. So first of all, I didn't talk about NUMA 0. I believe, is it Michael Carrington? Deepseek R1, $6,000. I got this whole idea from this X post. Are we calling it X now? I'm still calling it Twitter. Matthew Carrigan. Matthew Carrigan. All right. So credit where credit is due. This whole idea came from Matthew Carrigan, and somewhere in this atrocious X thread, he talks about NUMA groups and setting them to 0. So there's a lot of great info in there. You can totally read that if you want to. The way we do that is we go into the BIOS. Let's go ahead and do that. So you can go into the actual physical BIOS like on boot, or the IPMI has this neat little BIOS thing. And this is like, it looks like a totally different interface. But I think it has most of the same options. So AMD CBS, it just doesn't look the same. DF common options is the next thing we pick. DF common options, memory addressing. Oop. NUMA nodes per socket. It's this one. And this, by default, is auto. But we change it to NPS 0. And that is supposed to have some sort of a beneficial effect for running LLMs. I have not tested this in any other configuration, so feel free to play around with it. But Matthew Carrigan says that it is important, and I think that I remember reading in a AMD supercharging for LLMs document, an official AMD document, that this is actually a thing for optimizing for LLMs. So definitely do that, I think. And then, or actually don't do it, and then do it and see which one's better. I just haven't tested. And then for the RAM, so we go into the BIOS, we go to, again, AMD CBS. I'm a little tired if you can't tell. Then we go into SMU common options. Like, I have no idea what SMU stands for. Okay, so Jimmy said that it was SMU, but I think he meant UMC. I think that was just a typo. So let me just fix that while I have you right here. Sorry. UMC. Okay, sorry about that. UMC common options, and then just refresh this so we get the new version. Enforce POR. There we go. Accept. I mean, if you're just like clicking around in this, like who the fuck knows what any of this means, right? Like, so esoteric, but whatever. Memory target speed. So right here, memory target speed, and then you just set it to
I guess it doesn't auto detect properly, so you just set it to 5600. Anyway, that worked for me. I can prove it. So when I run sudo DMI decode -- type 17, I get all of this crap. It's just like a listing of the DIMMs that are on the machine and configured memory speed, 5600. Also, it shows up in the inventory. So what effect does that have on actual performance? Well, I don't know, honestly. It seems like maybe it's a little skippier. I don't think it's a huge deal, but maybe things are a little faster, maybe they aren't. So, but it's nice to have them running at the speed that they should be at. All right, I'm gonna go catch some Z's. I'm tired. See you. All right, future Jesse here. No discussion of an LLM machine would be complete without a discussion about context lengths. I have updated the README here for the Larry thing on GitHub, and what I've done is I've set the default context length to 16K in the Ollama service, and I've also turned on networking. Well, I've made it accessible. I've exposed Ollama's API to my local network. So if you're doing this on an insecure network, this is not a good idea. But I'm doing this on a private network, so it's fine for me. I have my Ollama keep alive set to -1 so that the models don't get recycled after 5 minutes. And I've turned on num parallel. I've set that to 1. So I think it defaults to 4. And basically what that means is that there's going to be one instance of Ollama available at any given point in time. And this serves to reduce memory utilization. So the default Ollama context length is about 2K. And with 2K context length and that 4 Ollamas in parallel, that'll fit within my my RAM on this server just fine. I think I have like 768 gigabytes of RAM. But if you set the context length to 16K and you leave that at 4, it says, no, I can't do that. I actually need a terabyte in order to function. And I have recorded that error message right down here so you can see what it looks like. Model requires more system memory, 996 gigabytes than is available, 747. So you'll need at least a terabyte, probably a little bit more than a terabyte of RAM in order to have 4 16K contexts available. That also means, I think, that you would be able to run a single 64K context. So this is important because in my experience using OpenHands AI for agentic coding, a 16K context length is probably not going to be realistic for most tasks. I would need at least, I would say like a 40K context length, maybe even like 60K for, to do useful work. So probably in order for this machine to do useful work in an agentic coding context, I would need a little bit more than a terabyte of RAM. So keep that in mind if you're going to build a machine like this of your own. That's important. Okay, the next cool thing that I've done is I've run Open WebUI. So I showed earlier using Ollama on the command line through SSH. That's not real super great for like copy and pasting code. I don't really like it at all. So what you can do is you can install Docker Desktop. This is a Mac that I'm recording this on right now. It's a MacBook Pro. I just have Docker Desktop installed, and you just run this one-liner, and it basically says you'll have to change this URL to whatever your server's URL is, but mine is aliased as Larry on my local network. Ollama runs by default at 11.4.34. That's the port, and it's going to start the Open WebUI on localhost at port 3000. So let's take a look at what that looks like. This is really cool. So if you're familiar with ChatGPT, it's just like a regular ChatGPT interface. And so you can click New Chat, and you can say, give me a recipe for strawberry muffins. Now, what I've noticed is that, oh, that was pretty quick. So sometimes when you go from like a very large context to a small context, there is, just in like the input text or whatever, there's about a minute delay as it like, I assume it's clearing the buffer out or something. I don't really know what it's doing. But that was very, very fast. So it's not always that fast. So you can sort of see it replying in real time. This is probably 5.5 tokens per second that we're seeing here. The crazy prepper in me thinks about using LLMs in a apocalyptic scenario, because it's kind of like they have like the sum total of the world's internet knowledge baked into them. So if you had like a access to an LLM in an apocalyptic scenario where the internet is down, you would basically have like all of the world's knowledge kind of baked into one little machine. It's kind of a cool idea. I don't know how that would work with hallucinations. I don't know how much of that is actually true, but it's just kind of a neat idea because we all use it instead of Google searching these days. Okay, anyway, so if I click, if I just mouse over this little eye icon, I can see response tokens per second, 6.68, so pretty fast. Prompt tokens, so what I sent to it was only 11, and then completion or total tokens is 621. So, that's well under that 16K limit. This was totally fine. So kind of neat. And then if you want to start a new chat, you just click on this. Now there is, over here in controls, there is a way to set the context length right here. But what I've noticed is that if you change the context length, every time you change the context length, the ollama service will reload the model. And on my machine, reloading the model takes at least 4 minutes. So kind of an expensive big deal on this machine to have to reload the model. You really want to not have to do that if you want to be productive. Oh, and then let's take a look at the sensors here. Sorry, I get excited. This is fun. Yeah, so let's do this. I didn't give you an idea of how much heat this thing was generating before, so let's do this again. We'll do, give me a sourdough bread recipe. It's kind of a long one, so let's see how fast it comes back. It might take a minute to come back, because like I said, I think it clears out the context in memory. There we go. That was pretty quick. So it's burning along now. And so we can see the CPU temperature come up when that happens. My CPU 0 always runs a little hotter than CPU 1. Might be a thermal paste issue. I'm not really sure. Might just be, I think the disk is on CPU 0. It might be something like that. My LAN's always kind of hot. But anyway, yeah. So even with 120 millimeter fans, I've got 520 millimeter fans. I installed one in the back off camera. The CPU temperature only comes up to about 60 C, which is not great. I would like it to be lower, but it's not bad either. It's workable. 61 C. You're making me a liar. It probably gets a little hotter than that.
All right, so here's Larry with just kind of idling. It's got an LLM loaded. It's got Deepseek-V3-0324 671b-Q8 loaded. but it's not actually processing a prompt right now. And it's drawing about 115, 120 watts, something like that. So let's query it for something. Write a poem. All right, and as it's doing that, we'll look at the wattage. So it's going up to 604, and I've seen it get as high as 670 watts. And then it kind of goes back down. And when it's loading the model into RAM, it draws about 500 watts. And then also when it's completely off, like if I power cycle it down, but the motherboard's still plugged in, it draws about 18 watts. So just in case you were curious what real world usage looks like on this thing, power-wise.
I'm editing this video and wrapping everything up today, and my conscience would not be satisfied if I didn't take a moment and talk about context length as it pertains to the length of the conversation and tokens per second. So I've been playing with this for about a week now, this system, Larry, and what I've learned is that after 4 or 5 messages or replies in the conversation, Larry starts to become annoyingly slow. Let's see if we can replicate that in a sort of a faux coding session. And I want you to think about this in terms of agentic coding, because when I use something like OpenHands AI to work with ChatGPT 4.0 or Claude via the API in an agentic context, I expect them to be really quite fast and quite responsive. And I don't see that out of this machine. What I see is sometimes minute-long turnaround times before it'll respond as the length of the conversation gets longer. So this is Deepseek-V3-0324, 671b Q4. Okay, so I've lowered the quantization of the model to Q4 from Q8, and this is Q4KM. And what this allows me to do is it allows me to raise the context length from 16K all the way up to, like, I believe it's 64K. However, you'll see that I can't use anywhere near that much context length for this reason. So let's do a quick coding session and you'll see what that looks like, hopefully. So I have, I have a couple of, I like jujitsu. I'm just a crappy white belt, but I go to jujitsu quite a bit. And there's this concept in jiu-jitsu of void belts. So this is like a way for you to kind of think about the difficulty of a match based on your age versus your opponent's age, and their weight versus your weight, and their skill level. So like their belt, their jiu-jitsu belt versus your belt. And so all of those things sort of like factor in when you try to decide like whether the match is equal or not, right? Weight classes aren't really enough. So I wrote this code to calculate like a void belt difference in a couple of different languages. So one language is JavaScript, and let's take some of this JavaScript code. We're gonna have Q4 here, V3Q4. We're gonna have it code in JavaScript because that's the easiest. I haven't tried this yet. So we're gonna say we have some code. We're going to give it a file name. I usually do like this. This is markdown syntax, JS. We're going to do some vibe coding here. All right. And we have some unit tests written in Swift. Now, take a look at those. And this is going to be in the tests directory. Blardy, blardy, blar. Okay. Copy that. Swift. Boom. Pasting all of that. So this is already a pretty long chat as far as just the length of the prompt goes, right? So we're going to say, please rewrite or please transcode the tests to JavaScript so that our JavaScript code has unit tests. Use jest. What else do we want it to use? I think that should be fine. All right, let's send it. Now we wait. All right, now I believe that wait was the model reading the prompt because there's a tokens per second associated with it reading that prompt. And now we're seeing in real time the tokens per second for the Q4 model, outputting a response. I have a system prompt set up telling it to not give me lists and to be concise if it can. It's the same system prompt that I use with ChatGPT. So if we mouse over the I here, we see that the prompt tokens per second was 40.09. So it read that fairly quickly. The response tokens per second was 8.37, and the total tokens was 1190. Okay, that's good. So we're just gonna do some vibe coding here. We're gonna try to put this on the command line. I don't know if this will actually work. I haven't actually tried this yet with this particular model. I don't know if it's gonna write working code or not. Copy that, paste it in. Oop. Okay, and let's see, npm install. Is there a package JSON? There's not a package JSON. Well, this will be a great follow-up. Please create a package JSON for this code and test. I want to run npm test and have it run my tests. Okay, so now it's going to have to read, I believe, all of that context. I mean, I'm not an expert on LLMs, so I don't really know how this works, but I think it's going to have to read the entire conversation before it gives this response. So it'll probably be pretty slow. I normally, when I do these videos, I normally will speed up time so that you're not bored. But I'm going to leave this in real time so that you can appreciate how slow or how fast it is, depending on your perspective. I don't know if you're an optimist or a pessimist. Okay. So if we look at this, we see that now our total tokens is 1514. prompt tokens were 1218. So even though I only sent this text here, it had to parse through everything above it in order to get to the output, to the response, right? So let's copy this package JSON, and then we'll do one more prompt after this, just depending on how this goes. Do npm install. Okay. And let's try npm test, see what happens. Okay, so we got some errors, right? So first of all, let's just make sure that the code is exactly what I told it the code was going to be, because I have some additional stuff in here. So let's remove that. I don't want that in there. Okay, so it's still failing. So in typical vibe coding fashion, I'm going to give it the whole response here, all of this. And I'm going to say, fix these tests. This is what I would do with an LLM in an agentic context. And we'll see what it says. So it's going to have an even longer context to parse through now. So it should theoretically take longer for it to respond. What is this, the third prompt? We're 3 prompts in now. In something like the ChatGPT API or their web interface, this response would have been immediate. And you might still see like a tokens per second as it prints out its next response, but the processing of the conversation up to this point is like instantaneous in those systems. So it's probably right about this. I'm not exporting the function. So yeah, model exports. I think it's probably correct about that. Good job, Larry. You're a smart guy. Look at that. Larry's tests pass. So I just gave you a demonstration of vibe coding. That's exactly how it works when I do it. You can see when I mouse over the eye that our total tokens is now up to 2,333. We are nowhere near even 16K at this point, right? and we're never going to be getting close to it with these speeds, because by the fourth prompt, you're waiting, you know. So if you look here, the approximate total shows you how long it took to actually deliver this response, 2 minutes and 14 seconds, right? So it doesn't matter that your response tokens per second are 7.48 if it takes you 2 minutes and 14 seconds just to, get through the backlog of the conversation history, right? The context. So again, I don't know what the hell I'm talking about. Don't listen to me. But is this machine useful? Yes, definitely. It's really cool. I enjoy playing with it. Can I use it in an agentic context to vibe code for me or just be a coding agent? No, I don't think so, because it would have to have that instantaneous processing of the entire context in order for that to be useful and practical. Should you buy this machine or build it? That's up to you, man. I can only present the data and show you how it works. So I hope you found this video interesting or useful. And if you liked it, please subscribe. Thanks for watching. See you next time.